Hello everyone. Good morning and good afternoon. Welcome to today's webinar. I'm Lauren from InHand Networks. I'm the Key Account Manager for Asia Pacific region. Today, I'm delighted to co-host this webinar with my colleague Zilla. Zilla, could you please introduce yourself?
Yeah, good morning and good afternoon. I'm Zilla, and FAE at InHand Networks. And thank you for coming.
Okay, thank you, Zilla. Today, the topic we're going to discuss is remote manage your machines with IoT technologies. With over 22 years of experiences in the IoT industry, our company, InHand Networks, has established itself as a highly professional player in the field. And we're excited to share our insights with all of you. So let's get started. Today's content will be divided into 5 sections. In Chapter 1, we will provide a brief overview of the current status and challenges faced by many enterprises, especially the industrial industry. We will also discuss how IoT technologies can help these businesses establish a competitive advantage. Moving to Chapter 2, we will present a series of case studies to illustrate the process of remote managing machines. In Chapter 3, Zilla will conduct a live demonstration of how our platform enables efficient and intelligent business management. Chapter 4, we will focus on introducing our company, InHand Networks. It's mainly for providing a comprehensive overview for those who are unfamiliar with us. Lastly, in Chapter 5, we will reserve some time for the Q&A session. Zilla will be available for answering all the technical questions you may have regarding the. Let's move to our first chapter, challenges and solutions. Now, due to unfavorable economic conditions and various other factors, businesses are facing a wide range of challenges. Here are some typical examples that you may find familiar. The first one is large talent gap. The industry's complexity and technical demands create an urgent need for high-end talent. Secondly, high environmental pressure. Increasing environmental pressure awareness raises strict environmental protection requirements for industrial enterprises, leading to higher costs for compliance. And the third one is fierce competition. The industrial market is highly competitive, with traditional industries facing new challenges from globalization and technological advancements. At last, shrinking demand. Weak global economic growth, compounded by factors like COVID, has led to sluggish market demand. With an understanding of these challenges, the significance of today's webinar becomes apparent. We aim to use IoT solutions to assist business in overcoming these issues and even gain a competitive edge in the fierce market. So let's check out what we could offer to help with it. We provide products and solutions in 4 layers. For the first layer, which is the bottom one, since we need to remote managing the machines, we provide sensors, controllers, devices to acquire data from your machines. Then, how to deal with those collected data? We offer industrial routers, edge gateways, edge computers in our second layer to pre-process and transfer the collected data. Then the pre-processed data is further transferred to the cloud, which leads us to the third layer, the platform layer. You could use your own business platform, or we have offered 2 platforms, InConnect service, which enables you to remote manage your machines, and Device Manager. It's a free platform to manage all your in-hand devices. In short, we could provide cloud plus edge IoT solutions to suit different needs for different customers. Then how to apply this IoT solution? The whole solution would be aimed at 4 aspects, including equipment predictive maintenance, factory digitalization, public utilities digitalization, new energy digitalization. This description may be relatively brief and rough, making it a bit difficult to comprehend how it works. So we'll move to the case studies to better understand the process of it. So the first case we present is preventive maintenance. Now, let me give you a real example of our solution. We have a customer who is an air compressor manufacturer. We know the use of air compressors involves a lot of maintenance and troubleshooting. Traditionally, engineers patrol and check each machine at the customer sites on a regular basis. This implies a number of risks. For instance, equipment may not be maintained promptly in case of a fault, and downtime means huge losses. In addition, manual patrol and check also involves high costs. Some hidden problems may not be identified in time and can thus become security hazards. So large air compressor manufacturers generally install their machines at numerous different locations with different models, different systems, or even different communication protocols. So how to gather those data from thousands of remotely installed machines efficiently? How to acquire data from all of them, which have different data tables or protocols. Also, there are huge amount of data and a lot of data are invalid. So how do we acquire the data that we really need? With regard of those issues, we offer solutions as below. Data from on-site controllers, nearly 100 variables, including pressure, temperature, operation time, warning codes, fault codes, etc. They are collected by IG502 via Modbus or Ethernet or serial ports at intervals of seconds. With intelligent algorithm, the gateway stores and analyzes the data locally, filter the invalid data, and then send the processed data to the cloud, which saves bandwidth, relieves the workload on the cloud, and also improves the quality of the data. So the IG502 gateway connects to the customer's cloud platform through cellular networks, and it communicates to the cloud via HTTPS or MQTT protocols. Except customer's cloud platform, the IG502 could also be managed by device manager, while remote access to controllers through in-connect service. Also, these collected data could be forwarded to the local monitoring system through protocol conversion. The whole system can be accessed via web or mobile app at any time from anywhere. Users can view of the air compressors, configure, upgrade, and debug the machines remotely. This increases the operation efficiency of the equipments, shorten troubleshooting, lower costs for maintenance, as well as communication between air compressor manufacturers and customers, improving service and business. Also used in those equipments, the mechanical equipment, energy equipment, manufacturing equipment, construction equipment, agriculture, and medical. So let's see our second case study, factory digitalization. Here are some visualized value with data. So the first, General Electric, as you can see here, after they applied the digital factory application, the production line efficiency improves by 10%, and the equipment downtime is 20% down, and the rework rate decreased by 25%. It saves around 10 billion a year. For the Siemens, which is also our customer, the situation is basically the same. With factory digitalization, order cycle shortened by 50%, and equipment downtime reduced by 30%. Billions of dollars saved each year. And there are also some data of Dongfeng model and Sony for your references. All these figures demonstration the value of digitalization. And let me share another example. The factory has all kinds of machines like air compressors, robots, CNC machine stools that needed to be connected to the internet. Faced with increasing data to be uploaded to the cloud, how can we ensure quick access while reducing the pressure of cloud computing? Also, in different industrial production processes, due to various brands of automated devices, diverse industrial interfaces, non-uniform protocols, and poor opennesses, data collection is challenging. Then how can we deal with it? First of all, various production equipments and testing equipments in the factory are generally set up as LAN through industrial Ethernet switches, which we also provide. And then their production status, equipment status, and energy consumption data are collected through edge computing gateways, in this case, IG902, with data volume generally ranging from several thousands to several tens of thousands of points with collection frequency of second level. The IG902 can pre-process, filter, and clean the collected data. The processed data is then sent to the cloud platform via frequently used IoT protocols. The cloud platform can be deployed at enterprises' private data center or Microsoft Azure Cloud Service Platform. The platform enables alarm recording, remote monitoring, device management, and so on, thereby ensuring and improving the stability and security of equipment, and ultimately reducing the operating cost of enterprises. So let's move on to our part 3, digitalization of public utilities. Public utilities means infrastructures and services that serve the public interest, including energy, water, telecommunications, you name it. Water utilities have been working to improve their service and provide urban residents with clean, high-quality drinking water. IoT technologies enable smart remote management of secondary water supply facilities. It is required that the operation status of those facilities can be automatically collected, transmitted, and analyzed, so as to ensure preventive maintenance and better efficiency of water processing. The remote management system consists of automation devices like PLCs, sensors, meters, etc., and communication devices and the cloud. PLCs at the site of secondary water supply pump room and a sewage treatment plant work as controlling devices, with IG902, the gateway for communication and data collected from the site, including operation status of the water pumps, water inflow and outflow, pH value, force status, and so on. The IG902 collects and reads data from the on-site PLCs, store data locally. It communicates with the cloud via MQTT and then send data to the cloud so that the on-site equipment can be monitored and managed. So this solution could also be applied in the below scenarios like smart energy, smart water, smart transportation, smart city, and smart public facilities. As for the last part, digitalization of new energy. Here is a real use case of remote management of generators. The traditional solution of power company may be low level of intelligence, and automation makes it difficult to serve the needs of new energy management. In an era where everything is connected, it is essential that more advanced IoT technologies be applied in the power company. As you could see, data of, for example, the generator's voltage, current speed, vibration, oil temperature, oil pressure, etc., they were collected through the controller at varying intervals. And those collected data pre-processed locally and then uploaded to the cloud. The edge computer, in this case, EC942, managed by device manager, and remote access to the controller by internet service. This solution is similar to the previous cases, but just incorporates with more powerful edge computer, which is EC942. And here are some application scenarios. Smart grid, smart energy. As you can see here, I want to name it one by one. So let's talk about the products that mentioned in the previous user cases. The first one is IG502, which is one of our most cost-effective products. And it has gained honorable nomination of the Engineering Choice Awards in 2022. Here are some outstanding features of IG502. It offers LTE Cat4 and Cat1 options. It supports multiple industrial protocols like MQTT and compatible with multiple IoT platforms such as Azure, AWS, etc. It has various interfaces like serial ports, I/O ports, Ethernet ports, USB, GPS, Wi-Fi to connect to different devices. It also has powerful edge computing capabilities, intelligent data processing on the IoT edge, also Python programmable. On top of that, featuring industrial design makes the gateway works reliable under harsh industrial environments. It is compatible with 2 cloud platforms we provide, Internet Service and Device Manager. It is also dual SIM failover. And here is IG902, which is more suitable for solutions with relatively higher requirements for industrial grades. It is available with LTE Cat6, Cat4 cellular networks, Wi-Fi, and wired connection, support for multiple major industrial protocols, and can be adapted to private protocols. Also, support for multiple IoT clouds, local SCADA, and other third-party data acquisition platforms. With multiple interfaces, it could effortlessly connect it to PLCs of Schneider, Siemens, Rockwell, and more. IG902 also features powerful edge computing and data analysis capabilities, easily configured, built for developers with Python, and also Docker supported. Finally, here is our high-performance edge computer, EC942. It's based on Debian OS. It provides a secondary development platform which supports for C++, Java, Python, Net, JavaScript, and so on. And it is also supporting a powerful computing platform with an ARM Cortex-A55 processor and 4 GB of RAM and 16 GB of eMMC flash, which is easily for users to develop and port applications. And it supports secure boot, TPM, etc., to ensure the security of users' software and sensitive data. Support gigabit Ethernet and Wi-Fi to provide reliable and uninterrupted internet access, offering a mutual backup of wired network, cellular, and Wi-Fi, combined with our cloud platform in Cloud Manager. EC900, which is EC942, its deployment can be completed in minutes. Okay, so here is our live demonstration, and Zilla, please present.
So now I think you are more familiar with our edge computing gateways. Next, I'm gonna spend a few moments to take you speed up with the built-in Python app, Device Supervisor Agent. So the Device Supervisor Agent enables this gateway series to have the intelligent data collection and processing capability, and also enables to have the popular industrial field bus protocols analysis, like the Modbus, Ethernet IP, ISO, TCP, OPC UA, and we've been improving. Now we are capable of handling over 30 protocols. And also this Device Supervisor Agent gateways enables to connecting to the different major IoT clouds like Azure and also the Amazon AWS. And any other standard MQTT cloud can be connected to. And this in-hand device supervisor is developed by our in-hand R&D. So that means once you have the hardware and we have the device supervisor agent installed, and it provides you with the visual interfaces So it can help the users to collect data of various industrial protocols and pre-process the data locally. And the processed data will be updated to the cloud platform only with simple configurations. And we conclude to 3 steps. The first step to add your controller to the IG502, IG902. And the next step is to configure the measure points, and then you connect the MQTT cloud. And next, I will demonstrate how to use the device supervisor to complete these configurations. So in our office, we've already have the IG502, and it connects to the humidity and temperature transmitters via the RS485. So next, I'm gonna log in to the web page to configure it. And we use the device manager to manage all our in-hand gateways and routers. Since now, and I've already make it online on the device manager, so I can log in through the device manager. Go to the web management. So the IG502 is running. The Python engine is also on. And we go to the measure monitor to add the controller. We give the name transmitter. So as we mentioned, it can support 40 protocols. So now I'm gonna use the Modbus RTU. And the slave 1, RS485. So just keep the other parameters default. And then we will add the measure points to it. We're waiting for it to online. So once the button turns green, yes, it's online now. The measure point will be the humidity. The register address will be 40,001. We just choose the 4 and put 1. The data type is Word. And for the humidity, we use the % for the unit. And you can also do the simple data calculation. We just use the offset and zoom. I'm just gonna zoom out a little bit to times 0.1. And next one will be the temperature. And the address will be 40,002. For temperature, we use the Celsius degree. And I also have to zoom out a little bit to times 0.1. So we can see the humidity is read. Yeah, waiting for the temperature to be read. Yes, we can see the humidity and temperature is read. And for the alarm strategies, you can set up by yourself. So that means once the temperature and the humidity is over the specific data that you controlled, and you will send the alarm to it. You can view the alarms here. So now we just use the default groups. And the next step is to upload this data to the cloud. I already have the MQTT cloud here. So now I'm just gonna connect a client to the cloud. And we enable the MQTT cloud on the in-hand gateway. So the address will be, yeah, here is the address. And we use the client ID is defined by yourself. Submit. This WebSocket client is connected now, and we're waiting for, yeah, we can see also the Edge gateway is connecting successfully. So now we will publish the data we just read to the cloud. We give it a group 1 using the default group, and the topic will be the data group. And here you can also write your own Python scripts to process the data and to package the data. But now I just use the default Python scripts. And here we will subscribe to the topic we just write. It's the data group. And the QoS will be 1, the subscribe. You already see the data is transmitted, and this is a default group that you can also define by yourself, as we talked before. And here we have the data conversion. Yeah, now we have several data conversion that you can choose to. The data processing is quite simple, right? And next, I'm gonna hand over to Lauren to take you more familiar with who I am and who we are.
Okay, thank you, Zilla. Please wait a moment. Oh, sorry, please wait a moment. Okay, in the last, we are going to introduce about our company, In-Hand Networks, for those who are not familiar with us yet. As you could see, we were founded in 2001 as a pioneer in the IoT industry. So after 22 years of development, we have served and cooperated with many global companies like GE Healthcare, Schneider, ABB, Siemens. And in 2019, we built our brand new factory in Jiaxing, China, which is a beautiful place near Shanghai. And we'd love to have you to visit if you're interested. And we were listed on the stock market in 2020. So since we're a global company, we have offices in different places. In China is our headquarters, and USA is our overseas headquarters. And we also have offices in Germany and Canada. And we have more than 400 employees all over the world. What is quite special is that 1/3 of our employees are made of R&D team, which guarantee the quality of our products. Also, we were listed among top 10 IoT gateway vendors by Berg Insight. It showed that our products are recognized by many customers in the world. And we offer 16 hours per day, 5 days per week, free technical support. So you don't have to worry about the after-sale service. And here is a picture of our factory. It covers around 1,700 square meters, and with 7 production lines and 3,000 units can be produced per day. Our supply chain is both powerful and reliable. And we are proud to share that we hold numerous quality certificates, so you can trust in the quality of our products without any concerns. Okay, so for the last part, we have the Q&A session. So if you have any questions with the content of our webinar, please feel free to ask. You're just simply interested in IoT technologies, or you want to know more about our company, it's all welcome. So I think it's the content for today. Thank you all for joining us, and we'll present another webinar in the next few months, and we'll very welcome for you to join. Thank you. So goodbye.